Hi, everyone. Thanks for tuning in to the Printed Circuit Podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. In this episode, we'll focus on ECAD-MCAD collaboration. And here to join me in this discussion are two dear friends of mine and who are industry experts, Charlene McCauley and Terry Duffy. Thanks for being here, ladies.
Well, hi, Steph. We really appreciate you inviting us to speak about this subject.
Hi, Steph.
You two are definitely amazing at what you do, and you definitely bring it. So I'm very excited to have this dialogue. With that said, can you give the audience a brief introduction of yourselves respectively? So Charlene, you want to go first?
I currently provide ECAD-MCAD services through my company, McCauley Design Group. I've been in business since 2010. I moved here to Austin from Oklahoma to go to work for Dell, where I worked for 9 years as an employee there, and then ended up starting McCauley Design Group. And I also had a company in Oklahoma too. So this is my second ECAD-MCAD services company. And I also have taught at Austin Community College, the PCB design. When I first started out of community college, I was doing mechanical drafting on the board. And while I was doing that, they introduced me to taping printed circuit boards on a light table. So that was my first bout with doing PCB design. So I've been around in engineering for about 48 years. I've been a business owner for 23 of those 48. So I've been around a while and been doing PCB for quite a while.
Wow, that's amazing. Quite a background. Terry?
I'm a senior PCB designer for McCauley Design Group, and I've been a designer for about 6 years. I have a computer science bachelor background. I'm also took over teaching Charlene's class at
last
semester at Austin Community College. So that was my first year to start teaching. I actually took the class from Charlene several years ago, got hooked on board design and started working for Charlene, and we've been working ever since.
She did so well in the class that I had to ask her to come work for me. So I was always searching for somebody to help me out because I kind of started out by myself. I'd had different ones from Dell that would come to work for me after we all got laid off from Dell.
but we just clicked together.
Yeah, we just really click, and it works really well. So
you two ladies definitely bring it and are true masters, in my opinion. I've seen your work. I've seen how you two collaborate together, and you two are amazing together, especially when you're sharing.
Eyes at me.
Yeah, when you're sharing your insights, it's truly amazing, and the work that you produce is wicked. And I'll just leave it at that.
Well, we really appreciate that.
Believe me, it's my honor to have you guys here. So, though it may seem obvious, do you collaborate with mechanical engineering during the PCB design process, and why?
So we do. Right now, our largest vendor is Dell. So I worked for Dell. Now they're our top vendor. And so we do a lot of the feasibility study at Dell for the laptops, for the precision laptops, which is a lot of what we're talking about at PCB East or West coming up. That was a lot of the work that we did at Dell. So we had to collaborate with mechanical design, not just Dell's mechanical design, but other companies that were involved with the CAM work that we've been doing. So it's so important to have that up front because you can see the size of the board, the height restrictions, the interconnections between the connectors, the thermal cooling, especially for the laptops, is so important. It's a good idea to have.
I think it's necessary.
Yeah, because we provide MCAD also. I have a background in MCAD. I know what I need from MCAD to get the board started and get going, and then we can dig in and we just get additional information. I know what to ask for. So it's important to have it, to have access to the mechanical side.
Yeah, I agree. Terry, you want to add to that?
So I think it's absolutely important to have MCAD and ECAD together because the first time you take 3 or 4 days to rearrange a whole circuit because the mounting hole was off by a millimeter, or you found out, oh, you're too close to the thermal, so your inductor's hitting, or, there's all kinds of reasons that you have to redo So after you do it once, you check forevermore.
We're always digging into boards and we get it perfect like they want it. And we say there's no more room in this board to do any. And then they say, can we move the mounting hole?
Yeah.
And I go,
or your inductor is hitting the thermal by 0.5 millimeters. I'm like,
I'm always known for, I never say it's impossible. I always have to dig in. If mechanical wants to do something, I try to collaborate with them to get it done. And so it always works. It always comes about. So
I agree. I think today, especially with the complexities that we're up against, with the boards that we're facing in the industry, that collaboration between MCAD and ECAD domains, it's got to be seamless. It's got to be bi-directional, and it has to be constant. And I think you guys basically just reiterated that in your responses.
And you have to be able to work together and communicate together.
Communication is key. It's like real estate. It's like communicate. The way they say it. For real estate, they say location. And I think we talked about this last time when the three of us were at PCB East. Board design, you constantly have to be communicating throughout the entire process.
Yeah, when I taught the PCB design class, that's what I told my students. If you can't communicate, you might as well go somewhere else because you've got to be able to communicate with engineering.
Yes, I couldn't agree with you more. Let's move on to my next question. At what point in your career, respectively, did you realize the importance of MCAD, ECAD integration in PCB design and make the decision to implement it in your design process, especially as you evolved in your career?
So like I said, I started out as a mechanical designer. And so at that time, it was way back, but I was just drafting on the board, and then we had PCB designers taping boards. So at that time, I was introduced to how my input controlled what the board was going to look like and what I was providing them. It's always been an important part of my design process to make sure that piece is good and to work with, like we said, to work together trying to create a product that will fit into a laptop or anywhere else. So it's an important process, but I was introduced it from the very beginning to be able to provide that type of services.
Terry, you want to add anything, Terry?
No, Charlene she impressed on me the importance of it. She said, nope, you're going to have a height restriction there. And I'm like, okay. So
yeah,
she taught me very fast to make sure I check boundaries, height restrictions, keep outs, all those nice little things that affect your board.
I remember early in my career, before I really truly understood that MCAD ECAD collaboration, on a second revision of the board, I added a new circuit, and for whatever reason, I decided to move something just a little bit in an area that didn't need adjusting, and I ended up causing a collision mechanically in the fit after we got the board back. And that was like, okay, I'll never make that mistake again. And I'm sure you two have a story or two you could share or that you could recall.
Yeah, we're having a problem with thermal right now to try to get boards to fit together.
Interfering with our perfect design. How dare they change our design? No.
So you got to be able to let that fit in too.
Mm-hmm.
So you mentioned, some of the work you were doing at PCB East. You mentioned, the stuff you're doing at Dell and these last minute changes that keep nickel and diming and moving circuitry, especially with today's compact boards. They're already jam packed as it is. And they want to add just one more circuit, or like you said, they want to just move the mounting hole. And it just happens to be where you have all this serpentining done, or all this, length matching or tuning, especially near the memory.
Well, the problem is with moving that mounting hole, it affected how many boards? That one mounting hole was saying they need to move it on these designs for Dell. It was
like six
boards were affected.
Yeah.
So it was a mess. But
that just reiterates why MCAD ECAD collaboration has to be heavily integrated and seamless, and definitely bidirectional communication is key. So I'll tell you, let's move on to the next question. So what is your opinion about designing PCBs without MCAD collaboration, especially when it comes to the challenging boards? So we talked about so far why it's important. And now let's talk about or at least give me your opinion if you would see a company or how a company could get around it. Or I don't see how they could, but basically they're just taking a guess. I mean, give me your thoughts. Charlene, you want to?
Lately, we've been privileged to work with some big companies like Dell, which has a big mechanical department. But a lot of the work we do is the feasibility study. So a lot of times, even with Dell, we don't have mechanical input. We basically are laying out the boards, trying to get it to fit. And it really is missing if you don't have that, like your height restrictions, your restrictions on, both sides of the board and everything. So I always push, let's get it to fit, but I'm always searching other examples. Like we have other boards that we work with to see what kind of height restrictions do they have. Yeah. Because if I start laying it out and I kind of know that there might be some height restrictions, you're kind of wasting your time in a lot of ways, because you'll end up having to relay it out once you get some information from mechanical. So I always push for it, but I also have access to the mechanical tools to where I can help provide that service, to help with that information with the smaller companies. But it's an important thing. It's important to have it, because you waste a lot of time not collaborating with the mechanical people to make sure things fit properly.
Like Charlene said, you could potentially get a reference board or something similar. Like if it's going in a specific identical chassis, they could just give you a reference board or something. Or if you have like a standard structure board, like you're doing a little M.2 board or something, then maybe you wouldn't need mechanical input. But
we're always searching for it.
Right. We're always
searching for the information.
Because you want to make sure nothing is going to interfere with your board and how it's working. So,
Oh, I agree. This kind of really ties into the next question is, can you share any real project examples which ECAD and MCAD collaboration improved the design cycle? Because we talked about how it wastes time. Can you share how utilizing the MCAD ECAD collaboration process, how it actually improved your design cycle time?
One small change can cost you a week of production time. And like we were doing some helping with real-time development of the new CAM connector that's out. And so that process would have taken twice as long if we didn't interact with the mechanical and the electrical engineers and everyone involved. It was constant communication.
The engineer that we work with for this, we're talking about Dell a lot because that's the big thing that we're working with right now. But he told us that the process that we went through the CAM, it's called CAM, which we're going to talk about at PCB West. And so he said that process would have taken years. I mean, maybe 6.
It did take years.
Well, yeah, but maybe 6 to 10 years. We did it in 4 years. And it was a lot of collaboration with the mechanical people, the chip people, everybody that was involved. And so that really was a great opportunity for us to learn building a new product for the whole world is what we were doing. So
without good communication, that would have taken a lot longer.
From what you shared with me, like I said, at PCB East, there's a lot of late nights, a lot of pulling your hair out and a lot of let's be real. I mean, there's been a lot of times where you feel like, even me being a Marine, I'll say, a lot of times you feel like gritting your teeth and crying.
Yeah. Well, just recently I worked, 32 hours in 3 days, just about a week ago. So it's a constant trying to get things to fit. I do it because I enjoy it. I enjoy making things possible. And so that's why I can go forever sometimes.
She gets excited when they say this isn't going to work. And she says, oh, well,
exactly.
Okay, I take the challenge.
Game on, huh?
Yeah.
Uh-huh.
This was not one of the main questions, but I'll ask, in your data exchange format, because of the collaboration with the tools that you're using, are you using IDX, or using IDF, or using multiple things, especially because of the environment with all the different domains? Are you using a collaboration of DXF files and other, believe me, I've done Visio exchange, napkin exchange, you name it.
Yeah.
So Terry, I think the last time you and I were talking, we shared a lot of our horror stories of napkin drawings and stuff like that. So, I'm curious, is there a specific data format that it's in your sweet spot?
Well, we mainly use the IDF, EMN and EMP files, and then the DXF a lot. And we also use Kleenex boxes.
Post-it notes.
He's just Post-it notes to try to get the fit and the way it comes together.
Oh yeah, we
You know, we'll make
extensive Post-it notes. It goes on this side and this side, and you rotate this side, and oh yeah, it's.
But a lot of times I'll set up some DXF files where I can load in and do my own mechanical while we wait on big time engineering to do something.
Do their thing.
But we have to do the old way and do the piece of paper or Post-it to try to put it
Or
all
a lot
together.
of times you just get the PDF file and you have to put it in the file yourself. So.
Yeah.
This is a testament to both of your skill set and craft, because you take a collective of whatever it is, and sometimes it's like you just said, you're having to take bits and pieces and try to put it together, and you two are damn successful at doing it, because I've seen the complexity of designs that you guys have done and continue to do, and it's amazing.
You're looking for an answer, and you got to do the best thing possible to get that answer as quick as possible so you can get on down the road to get the board done. Like the projects we've been working on, when it first started out, it looks completely different now than it was when we thought, oh, this is what it'll end up. But it just continued to change for years. And it was a great experience to be involved in.
Part of the problem is things change so rapidly that just tell me what you want and I'll implement it, because our tools are so sophisticated now. You're able to do MCAD in ECAD world and vice versa, a little bit of ECAD in MCAD world. And they're so fast in the directions we're moving. And sometimes the change we got this morning is already rechanged or changed by the afternoon. Kudos to those of us who are able to survive and thrive in that environment.
We're lucky. We get to prove a lot of projects that say they can't be done. So we get to prove that a lot. So it's a lot of fun to do that. So
awesome. So I'll tell you, let me get to, my last and final question, especially when I think about, as experienced designers, what are some of the advice that you would give to the new generation that are just getting started, in the collaboration when you think about your career of MCAD, ECAD collaboration? So
the main thing that I always say, never give up. Even the women, if you're the only woman in the class that you're taking, that's okay. I was the only woman for a long time in all the classes that I had to take. Women in engineering, you've got an open door to any company you want to go to. If you're a good engineer, if you're a good communicator, if you like to do the design work like, we do with the PCB side, the door's wide open for you. Even with the AI products that are coming out, they still need PCB designers and mechanical designers. They need those people. So it's a great field to be in. I know when I worked at Dell, I went to a STEM program that was, I went with some engineers from Dell, and we went to the high school, the local high school, and we were volunteering for the STEM program, which that is the science, technology, engineering, and math. That's what it means. And we had the best time seeing all the high school students, even smaller students were there, and having a lot of fun doing a lot of science and math and technology things. And I really enjoyed that. So that's something maybe the younger students maybe look into to get to see if that even interests you. So there's a lot of programs out there that is encouraging science and technology. That's something that you like to do, that would be great. But as a woman, like I said, the door's wide open for you to get any type of job for any type of company.
Don't let the industry intimidate you. It might be a little overwhelming if you think about the career or you think about what you'll be doing. Or, even like Charlene was saying, if you're the only woman in the group, in these classes, or even if you're in a job, you should still just follow your passion. If you enjoy it, you should go for it.
I agree. I think I would say this, the majority of my career, not just my career, but the majority of my life, especially me having 4 sisters, I think equality is everything. I think what women can bring to the table, especially in engineering, I would love to see more women in engineering. I fully support STEM and what you guys are doing there with the local schools and the robotics clubs that you're part of and that you guys do there in Texas. It's amazing. And I can't thank you enough for helping set the bar for the younger generation to follow and a great example of not letting any hurdles get in the way. And if anything, you guys just break the barriers or go around them or go over them. So you two ladies are definitely examples. I know there's been a number of times that I've pointed people, to your direction or to use you guys as examples of not letting anybody hold you back because of your gender. And I'm so glad you mentioned that, Charlene, especially with the younger generation and a lot of younger women in the universities. They want to go into it, but then they get a little bit intimidated. Terry, as you mentioned, and some of them are amazing talent. And if they just have confidence in themselves that they can do it, the sky's the limit. Look at you two.
Well, it's been a great opportunity to be able to share what we do now. Before, like there's so many secrets that you work on, you're not able to share the product, what you're working on. Now, because of this product that we did for Dell, we're able to get out and start talking about things. And we do that through school, Austin Community College. I've been able to share a lot there, but it's kind of nice to do a podcast with you, our first podcast. And it's been exciting talking to you.
Yeah, it's been great.
Before I close this out, is there any last words or last bit of advice that you guys like to give, or even shout out? Hey, Charlene, I know your company's doing very well. Is there anything that you guys like to? Floor is yours. Have at it.
Go ahead.
I want to say, even if you're going in it as like an engineering world and you think, oh, it's just going to be design rules and all that, there's an artistic side to it. I mean, you can look at that board and say, wow, it's really pretty, which is different. That's one thing I really like about it is there's definitely an artistic side to it. It's not just straightforward engineering, numbers, rules, that kind of thing. You get to put your own flair and artistic side to it.
I mean, it's just like how I found Terry in my class at Austin Community College. I was always looking for somebody that I could bring on and train, and they could also help me with my work. And it's worked out really well with Terry, with her computer software or programming background. Mm-hmm. She was able to work in with the constraints on the circuit boards that I hate to do. I have to do, but I hate to do. And with her numbers knowledge, it really enhanced our design process. And so, I'm always looking for somebody that I can train. I love doing this. I love sharing it. I love teaching people to enjoy it like I do. And so it's exciting to be able to have that outlet at the school to bring in different ones. We've had different ones through here, and they've all gone off to get a better job. So it's exciting to be able to provide that. And I've really enjoyed teaching at the college and getting access to people like Terry to work with me.
Terry has had a great mentor in you. And Terry, that's not taking anything away from you, because I know you went from like 0 to 5 years, and within 5 to 7 years, you're doing extremely complicated designs that it's hard for me to understand, or just because I'm a designer and been doing it for so long, it's hard for me to really realize how quick you came up to speed. And that says a lot about yourself. But this goes to show, with a right mentor and a good student or a good mentee, look what you two have produced.
Well, I've had mentors in my life that taught me what I know too. And so I just want to pass it on to others. And so I've had some of the best mentors in my life.
Awesome. Well, with that said, let me close this out. That's pretty much all we have time for today. So thanks for both of you for sharing your insights on ECAD and MCAD collaboration. To our audience, continue to tune in for more trends, challenges, and opportunities across the printed circuit engineering industry.